Hey everybody, in this video I'm going to talk to you about parent functions and transformations of those parent functions. In my last video I introduced you to 9 different parent functions that we use in Algebra 2. Okay, and then I also covered the domains and ranges. So when you add or subtract numbers to, throw in a negative here, or throw in a +4 there, or throw in a ×2 there, something like that, that's considered a transformation. Alright, and so that'll ultimately change the domain and range a lot. Sometimes it won't. And we'll get into that in other sections. But in this video, I just want to go over how is that going to change, the appearance of the graph is ultimately what we're looking at today. So to recap what a transformation is, it's changing the size, shape, position, or orientation of a graph. So if you took geometry before taking Algebra 2, you did transformations, you did rotation, reflection, you did translating, and you did dilating, okay, and then you did like combinations of those. It's a little similar in Algebra 2. You have reflections, translations, and then instead of dilations, you have vertical stretches, vertical compression, and then horizontal stretch or compress. We don't really cover rotating in Algebra 2. Okay, but let's start with reflection. Reflection is simply flipping the graph. To flip the graph, you need a negative somewhere out in front. If you have a negative somewhere else, then you're just adding or subtracting a number somewhere else, and that'll either translate it up, down, left, right. A negative in front of the x term is basically what I mean. If you have it out in front, that's the best way I can describe it. On the outside, see parentheses, and then this is it in function notation, negative, and then of the function. So if the function was x squared, I have negative x squared now. That's going to reflect it over the x-axis. And if you have a graphing calculator with you, it's a good idea to graph x squared and graph negative x squared so you can see what I mean. I don't have the technology to show you that while recording this video on this paper. I can't go back and forth, sorry. But if you were to type it in on the inside, you'll reflect over the y-axis. So on the inside of the function is you're including the negative with the x. So you're doing negative x and then squaring it. That's going to give you a y-axis reflection. So it'll flip from side to side rather than from top to bottom. Okay? So it's important to know where the negative is. And that's going to tell you what kind of reflection you have. Now, translating is just moving it left or right or up and down. If you want to move it up and down, simply add or subtract a number to the outside of the function. So here, my most basic function would be square root of x. So if I just had square root of x, I'd have my square root function. But if I added 3 to the outside, the graph would go up 3. Now, if I wanted to add 3 to the inside, it would look like this. So I would have everything under the radical. That's what I mean by outside, inside in this context. Okay? Now, moving on. If I wanted it to go like down 3, I'd just write -3 on the outside. If I wanted to go up 8, I'd write +8, So it works just like that. Now, if you want things to move from side to side, you're going to add or subtract a number on the inside of the function, what I was just talking about with that square root one. So in this example, I use an absolute value example. So the outside would look like this, absolute value of x plus 2. That would be going up 2. So if it's on the inside, you have absolute value of x plus 2 now. That's the inside. So that's going to move opposite of what you might expect, which is this is going to get it left 2 units, okay? So shifts left 2 units. And then I put another example here. If you had -5 on the inside, that's going to go right 5 units. So that's a tricky one. People tend to forget that. So that's why I wrote this note. Translating left to right moves opposite of what you might expect. All right. So vertical stretching or vertical compressing. Okay. Looking at these, that's when you have a number like on the quote unquote outside again, but it's with the x. So you have like a 3x squared. That's going to stretch it. Any number bigger than 1 that's out in front is going to vertically stretch it, like pulling on it, like a rubber band. Okay, it's going to get taller or skinnier, however you want to visualize it. Um, if you have a negative, that doesn't matter. So, if I had a negative 3x squared, this thing would still be getting vertically stretched by a factor of 3. That negative is going to make it reflect, okay? So negatives have nothing to do with is it going to stretch or compress. Negatives just tell me is it going to reflect over the x-axis or the y-axis. That's all negatives will tell you, as if they're out in front, that is. You know, if they're on the inside, I just talked about that with the translating. So what if you have a number on the outside, but it's not a big number, it's a small number, like 1/2, for example. That's going to vertically compress. So it's like you're pushing on the sides, or vertically compress is like you're pushing down from the top. So you're squishing it. So it's going to get wider and wider, like you're squishing a ball of like silly putty or something. Um, and so again, negative numbers, aren't going to affect this. You want numbers that are less than 1 in terms of a, 0.9, 0.8, 1 over 4, 1 over 6, 2 over 5, something like that. As long as that you have a fraction and that the numerator is smaller than the denominator, then you're going to get some sort of vertical compression, okay? If I give you a fraction like 5 over 4, just because it's a fraction, don't automatically assume it's going to vertically compress, because 5 over 4, 5 is bigger than 4, so that's going to make a number bigger than 1. That's actually going to vertically stretch it, okay? But in this example right here, 1/2 x squared, this is something that's going to end up being twice as wide as x squared. So you just say it's vertically compressed by a factor of 1/2, okay? Now, the horizontal compression or horizontal stretch, it's a synonymous term to vertical stretch. If you're stretching vertically, you're pulling on the top and bottom. If you're horizontally compressing, you're pushing in on the sides, but by doing that, you're making it get skinnier. The top and bottom are moving upwards or downwards. Okay, but you're gonna use the vertical terms, vertical stretch, vertical compression, when the number's out in front, okay? There's no parentheses, it's out in front of the x. If it's included on the inside with the x, you'll use horizontal compression, okay? Or horizontal stretch, depending on the number that's out in front. If the number's bigger than 1, horizontal compression. If the number is smaller than 1, horizontal stretch. Okay, so that's an important thing to note. I know it can get confusing, so just try and think about where that number is included. Is it included with the x? That would be considered the inside. Or is it just like next to it? So that would be considered the outside. Okay, so with that being said, just kind of want to recap what we've done here. This is just a general formula. If you have a number out in front, this a, what is that a going to do? That a is going to stretch or compress. It could be vertical stretch, horizontal stretch, it depends. But just knowing that if you have that number out in front, it's going to stretch or compress it. And then I just added, if it's negative, it'll reflect. It won't, it won't change the stretch or compress, but it'll make it reflect either over the x or over the y. Okay, so this minus h, that's on the inside. See, it's grouped in with parentheses, it's with the x. So, what's that minus h doing? Well, minus is going to make it go to the right, and plusing it is going to make it go to the left. Okay? And then that number, the k, what is that k going to do? Well, plus k will make it go up, and minus k will make it go down whatever unit, because that k is all the way on the outside. And so if you just kind of remember this, chances are you'll be okay. And you can always use the graphing calculator to, kind of verify things. But always compare back with the original parent function, though. But yeah, so I just called this a quick guide. I don't know what else to call it. But it's kind of like loosely sums up everything that's up here in all this text, all this important stuff. That being said, let's just do some examples. I'm going to identify the function type and describe the translation or translations. So looking at this, if you get stumped on the function type, use the notes that were in the prior video. Look at the picture. Does it look like one of the parent function graphs? Type it into the graphing calculator, look at it, and then compare it to, the parent function graphs. And then also just look at how it's written down. Negative 5x plus 2. I just have a singular x. So that cues me to that it's going to be a linear function. And now I just need to think about what did this negative do, what did this 5 do, and what did this plus 2 do. That negative is going to make it reflect, and it's on the outside, so it's going to go over the x-axis. That 5 is going to make it stretch vertically because it's on the outside. There's no like parentheses. That plus 2 will make it go up 2. Alright, not left 2 or right 2. It's not inside on the parentheses. And yeah, so just pay attention to how it looks. Okay, let's move on to the next one. This one, it has x in the exponent, so therefore it's an exponential function. Alright, I have a minus 1. That's on the inside because it's with the exponent. That's where the x is. The x is in the exponent, so if I'm subtracting 1 next to it, it's on the inside with the x. So therefore, that's going to make it go left or right. And since you see minus 1, you might think, oh, it's going to go left 1. No, it's going to go right 1. If you want to graph it, graph e to the power of x, and then graph e to the power of x minus 1, and you'll see that it's just 1 unit to the right. It looks like the same graph, but just moved over 1 spot. That plus 3 is on the very outside. See how it looks very different than that minus 1. So that's just going to make it go up 3. Okay, so I changed that to a blue circle so everything's color-coded. Again, if you want to see it shift up 3, type in e to the x, and then type in e to the x plus 3. If you type it in all at once, it's harder to see it. Like if you typed in this whole thing, it's harder to see it all at once. So that's why I recommend typing into the calculator individually if you ever get stumped, one transformation at a time. Okay, that being said, I want you to work on these on your own. There are a bunch of examples. Name the function type, and then describe the transformations. So what I'm going to do is I'm going to pause, well, you should pause, work on it, and I'm about to show you the answers, okay? Okay, so here are the answers. There's a lot of problems, and I don't really want to explain it because I don't want the video to run too long. I'm already about 15 minutes here. So what I'll do is I'll just kind of slowly pan through it, and you can pause if you miss something, and then just leave me a comment if you have a question over any of these, and yeah, and I'll get back to you. Okay, so that's everything on the left side. So let's go with everything on the right side, going from the bottom up. And then I tried, if you notice, I tried color coding all my answers. Um, so hopefully that helps. Instead of having a bunch of arrows pointing to this and that, I color coded everything. So that covers all the problems. I hope this video helps. I'll see you on the next one. Bye.